The spring of 1918 arrived across the American Midwest with the particular cruelty that only that season can deliver, warm enough to promise life, cold enough to punish optimism. The fields stretched in every direction, brown and expectant, waiting for the plow. And across those fields, for the first time in significant numbers, a new kind of machine was moving. It coughed and rattled and belched smoke. It smelled of oil and hot metal and burning kerosene. It was louder than anything a horse had ever been and more powerful than any single animal a farmer had ever owned. It was the Fordson tractor, and it was going to change American agriculture forever. It was also, in ways that would take years to fully understand, going to kill a remarkable number of the men who operated it. To understand what happened in those fields during the teens and 20s of the 20th century, you have to understand something about the world that Henry Ford was trying to disrupt. American farming in 1915 was exhausting, backbreaking, and fundamentally archaic. A farmer with a team of horses could plow perhaps 2 acres a day under good conditions. He spent a significant portion of his income feeding those horses through the winter, whether they worked or not. He spent hours every week in the care and maintenance of living animals that could get sick, go lame, die, and refuse to cooperate on any given morning. The horse was simultaneously the farmer's greatest asset and his greatest liability, and every farmer in America knew it. When Henry Ford began seriously developing what would become the Fordson tractor, he was doing so from a position of deeply personal understanding. He had grown up on a farm in Dearborn, Michigan. He had walked behind horses through wet clay soil. He had felt the particular fatigue that comes from physical labor that never quite ends, that begins again every morning regardless of what happened the previous day. Ford hated farm work with the specific passion of a man who had escaped it through genius and will, and he was determined to liberate other farmers from the same drudgery. He believed, genuinely and with the evangelical fervor that characterized so much of his thinking, that mechanization was the answer. The tractor was the tool, and he intended to make it available to every farmer in America, not just the wealthy ones. The Fordson Model F went into full production in 1917, and what Ford had accomplished in its design was genuinely extraordinary for the time. He'd created a tractor that sold for $750, dramatically less than competing machines that cost 2 and 3 times as much. He had applied the assembly line principles he had perfected with the Model T to agricultural machinery, creating a standardized, mass-produced machine that could be maintained with common tools and ordinary mechanical knowledge. The Fordson had no frame in the conventional sense. Its engine block, transmission, and rear axle housing were bolted directly together to form a structural unit, which reduced weight and complexity simultaneously. It weighed approximately 2,700 pounds. Its 4-cylinder engine produced around 20 horsepower at the drawbar. It could pull a 2-bottom plow through most Midwestern soils without difficulty. It was, by every measure of the era, a triumph of engineering and manufacturing. It was also, in certain fundamental ways, a machine that had been designed with insufficient attention to the conditions under which it would actually be used. This was not immediately obvious. It was not obvious to the engineers who designed it, or to the dealers who sold it, or to the farmers who bought it with their savings and their borrowed money and their desperate hope that this machine would finally make the difference between scraping by and getting ahead. The danger was hidden in plain sight, encoded in the basic geometry of the machine, waiting for the precise combination of circumstances that would reveal it with sudden and irreversible violence. The Fordson was tall for its weight. Its rear wheels, large iron affairs with protruding lugs for traction, stood nearly 5 feet high. The engine sat forward of the front axle, which helped weight distribution in some respects, but the overall configuration meant that the machine's center of gravity was located at a point approximately 24 to 26 inches above the ground. In modern terms, this sounds unremarkable. In the context of what happens when a tractor encounters resistance at its drawbar, it was a design characteristic of lethal significance. The physics involved are not complicated, though their consequences are severe. When a tractor pulls a load through its drawbar, the point at the rear of the machine where implements like plows are attached, it experiences a rearward rotational force. The rear axle acts as a fulcrum. The heavier and more resistant the implement, the greater the rotational force trying to lift the front of the tractor skyward. In normal ploughing conditions, with properly adjusted equipment and experienced operators, this force is manageable. The weight of the engine over the front wheels resists it. The tractor pulls its implement and moves forward, doing the work it was designed to do. But conditions are not always normal. Soils vary. A plow moving through soft earth suddenly encounters a buried rock, a tree root, a hardpan layer, and the resistance increases instantaneously and enormously. An operator makes an error in the setup of his implement, attaching it at the wrong angle, or allowing it to dig too deeply. The terrain slopes upward, adding gravitational force to the rotational moment. The throttle is opened too quickly, delivering power faster than the traction of the rear wheels can absorb it. Any one of these conditions, or several of them in combination, can tip the balance past the critical point. And when a tractor reaches that critical point, when the rotational force lifting its front wheels exceeds the restoring moment of its weight, the machine does not hesitate or warn. It does not slow down and topple gradually. It rotates backward with a speed that consistently astonished witnesses, completing a full rearward arc in less than a second, pinning its operator beneath its weight before any human reflex could respond. The Fordson had specific characteristics that made it particularly susceptible to this kind of accident. Its wheelbase, the distance between the front and rear axles, was relatively short at 63 inches. This meant that the lever arm resisting rotation was shorter, which meant the tipping moment was reached more quickly and at lower levels of applied force. Its rear wheel tread, the width between the two rear wheels, was approximately 42 inches, which was narrow enough to limit lateral stability without addressing the more fundamental problem of rearward stability. The machine's engine, while not extraordinarily powerful by later standards, was powerful enough to deliver the rotational force necessary to lift the front wheels under challenging conditions, especially when operators were inexperienced with the machine's behavior or when field conditions were more demanding than anticipated. There was another element that made the Fordson's rearward tipping tendency especially treacherous. Unlike earlier tractors that used a friction clutch with a gradual engagement, the Fordson's worm gear rear axle created a situation in which, under certain conditions, the drivetrain could experience a sudden locking effect when the implement was deeply engaged in hard soil. Operators sometimes referred to this phenomenon without fully understanding its mechanics. When a plow caught hard ground and the tractor's rear wheels momentarily stopped moving, the engine's continuing effort had nowhere to go except into lifting the front of the machine. The worm gear design, praised for its mechanical simplicity, contributed to a condition where power delivery could not be modulated fast enough to prevent the rotational moment from becoming catastrophic. The men who operated these machines in the late teens and early 20s were, for the most part, farmers who had spent their entire lives working with horses. They understood animal power intuitively, understood the way a horse would resist an unreasonable demand, understood the warning signals that preceded a problem, understood the fundamental principle that a living animal had self-preservation instincts that would sometimes override a farmer's commands and thereby prevent a disaster. The Fordson had no self-preservation instincts. It had no warning signals that a farmer could read from long experience. It would do exactly what its throttle and its implement setup demanded of it, right up to and including the moment of catastrophic failure. A farmer named Elmer Schultz, working land outside Abilene, Kansas in the spring of 1919, described an incident that he survived only because he was thrown clear during the initial rotation. "She came up so fast I didn't believe it was happening," he told a county extension officer who was documenting the accident. "1 second she was pulling fine and the next second the front end was in the air and I was falling backward off the seat. I hit the ground and she came right over where I'd been sitting. If I'd stayed on, she would have crushed me sure." Schultz had broken his collarbone in the fall. The tractor had landed on its steering wheel and radiator, suffering damage that took weeks to repair. Schultz considered himself fortunate, and he was correct in that assessment, because many men in his position did not have the opportunity to be interviewed afterward. The statistics from this period are incomplete, because the systematic collection of agricultural accident data was still in its infancy, and because rural accidents in the early 1920s were frequently underreported. Death on a farm was sometimes recorded simply as accident, without further specification. County coroner records from agricultural states show a consistent pattern of deaths involving tractors, but the cause, whether rearward overturn, side overturn, or some other mechanism, was not always specified with precision. The Nebraska Tractor Test Laboratory, which began its standardized testing program in 1920, accumulated incident reports from farm bureaus and extension services across the state, and these records provide some of the most detailed documentation of the problem's scope. What those records reveal is sobering. In Nebraska alone, between 1920 and 1930, tractor accidents killed approximately one farmer for every 1,000 tractors in the state annually. As the number of tractors grew dramatically through the decade, from around 15,000 in 1920 to nearly 100,000 by the end of the decade, the absolute numbers of fatalities increased correspondingly. Nationally, estimates from the period suggested that tractor accidents as a category were killing between 300 and 600 American farmers per year by the mid-1920s, with rearward overturns accounting for a disproportionate share of the most severe injuries and fatalities. A 1928 report by the United States Department of Agriculture characterized the situation as a public safety crisis of the first order, and noted that the mortality rate from tractor accidents was significantly higher per machine than the mortality rate from automobile accidents, which were themselves the subject of growing national concern. The Fordson was not the only tractor involved in these accidents. Every tractor manufacturer of the era produced machines with similar fundamental vulnerabilities: high centers of gravity, relatively narrow wheelbases, powerful engines, and attachment points for implements that created the same rotational dynamics. But the Fordson, by virtue of its price and its availability, and Henry Ford's extraordinary marketing capabilities, had become by far the most common tractor in American fields. By 1923, Fordson tractors represented approximately 75% of all tractors sold in the United States. This meant that when the safety problem became visible in the statistics, it was Ford's product that was most prominently associated with the danger. The farming community's awareness of the problem grew through channels that were characteristically rural: word of mouth at feed stores and grain elevators, reports in farm newspapers, discussions at grange meetings, and the simple accumulation of personal experience and witnessed tragedy. A farmer who had seen a neighbor's tractor flip would talk about it. A county extension agent who had visited the site of a fatal accident would include a cautionary passage in his next newsletter. The farm press, publications like The Prairie Farmer, Wallace's Farmer, and the numerous state agricultural journals, began publishing accounts of tractor accidents with increasing frequency through the early 1920s, and some of these accounts were remarkably specific about the rearward overturn problem. A correspondent writing in Wallace's Farmer in 1922 described the experience of visiting a farm family that had recently lost their father to a Fordson accident. "The widow showed me where it happened," he wrote. "The marks in the soil were still visible, the furrow where the plow had caught, and then the ruts where the back wheels had dug in as the front lifted, and then the wide, flattened area where the machine had come down. She told me her husband had been operating the tractor for 3 seasons, and had thought himself experienced with it. He had no reason to expect what happened. None of them ever do." The correspondent went on to urge caution and the adoption of safe practices, though the specific content of those safe practices was vague, partly because the agricultural community had not yet developed a coherent body of knowledge about how to prevent rearward overturns. The problem attracted the attention of agricultural engineers at the land-grant universities, who began systematic study of tractor stability in the early 1920s. Researchers at Iowa State College, the University of Wisconsin, and Kansas State Agricultural College conducted experiments measuring the tipping angles of various tractors, calculating the geometric relationship between center of gravity height, wheelbase length, drawbar height, and the forces required to initiate a rearward overturn. What they found confirmed the worst fears of those who had been tracking the accident data. The Fordson, in particular, could be tipped rearward by drawbar forces that were entirely within the normal range of agricultural operations. A plow catching in moderately hard soil could generate sufficient resistance to exceed the machine's stability threshold under conditions that an operator might reasonably encounter on any given day in any given field. The researchers also documented something that made the problem more insidious than it might otherwise have been. Operators who had used a Fordson for several seasons without incident had typically developed a false sense of security about the machine's behavior. They had learned, through repeated experience, that the tractor would pull a plow through a wide variety of soil conditions without tipping. They had seen the front wheels lift slightly on challenging terrain, and had watched the machine recover and continue working. From this experience, they had drawn a reasonable but incorrect inference, that the machine was essentially safe, that its tipping tendency was something they had already encountered and survived, and that catastrophic overturn was something that happened to other, less experienced operators. The researchers found instead that experienced operators were not significantly less likely than novices to be involved in overturn accidents, because the conditions that caused catastrophic overturn were often sudden and unpredictable, unrelated to operator skill or experience. Henry Ford himself was not indifferent to these reports, though his response to them reflected the complicated mixture of genuine concern and commercial defensiveness that characterized much of his public posture on controversial subjects. Ford's engineers were aware of the stability problem. Internal correspondence from the Ford Motor Company, some of which eventually became available to historians, shows that engineers at Dearborn were receiving and discussing reports of tractor accidents through the early 1920s. The engineering response, however, was constrained by the same imperative that had driven the Fordson's original design, the need to keep the price low enough for ordinary farmers to afford. Significant design changes that would have improved stability, such as a longer wheelbase or wider rear wheel tread, would have added manufacturing complexity and cost. The machine's commercial success depended on its affordability, and its affordability depended on the design remaining essentially unchanged. The company's public communications about tractor safety during this period focused primarily on operator training and practice, rather than design modification. Ford dealers were encouraged to instruct buyers in proper operating technique. Pamphlets were distributed discussing the importance of keeping plows properly adjusted and avoiding conditions that might cause the implement to dig excessively. These instructions were not without value. Operator error genuinely was a contributing factor in many accidents, but they addressed the symptom rather than the underlying condition. They placed the burden of safety entirely on the operator, and implicitly suggested that accidents were the result of improper use rather than inherent design vulnerability. The critics were not silenced by this approach. Through the mid-1920s, voices in the agricultural press and the land-grant university extension services grew more pointed in their assessment of the problem. A 1924 bulletin from the Iowa State College Extension Service noted that the present design of many tractors, including the most widely used types, creates conditions under which a rearward overturn can occur with such rapidity that no operator, regardless of experience or attentiveness, can take effective corrective action. The solution to this problem lies in design rather than in education. This was a carefully worded but unmistakable indictment of the Fordson and its contemporaries, issued by an institution whose primary mission was the service of the farming community. The competitive landscape of the tractor market began to shift in ways that reflected the growing awareness of safety issues. International Harvester, Ford's primary competitor, introduced the Farmall tractor in 1924. While the Farmall's design also had potential stability issues under certain conditions, it incorporated a different overall geometry, a tricycle configuration with a narrow front axle and wider rear spacing, that addressed some of the Fordson's specific vulnerabilities. More significantly, International Harvester's marketing materials for the Farmall explicitly emphasized the machine's stability and ease of control, a competitive message that would have had no effect if farmers had not been aware of and concerned about the overturn problem with existing machines. Sales data from the mid-1920s tell a story that the manufacturers understood even if they did not discuss it publicly. Fordson sales, which had dominated the market through the early part of the decade, began to decline in 1925 and continued to fall through 1926 and 1927. Multiple factors contributed to this decline, including the Farmall's popularity and the general improvement in competing machines from other manufacturers. But the safety reputation of the Fordson played a role that contemporary observers noted explicitly. Farmers who had heard accounts of overturn accidents, or who had witnessed them, or who had lost neighbours or relatives to them, were making purchasing decisions that reflected their awareness of the risk. Henry Ford, who had never willingly abandoned any market, finally ceased American production of the Fordson tractor in 1928, a decision that reflected the machine's declining competitive position in a market that had moved beyond it. The withdrawal of the Fordson from the American market did not solve the underlying problem, because the same design vulnerabilities existed in competing machines. What it did was underscore the economic consequences of ignoring safety in a product intended for a consumer who could choose alternatives. Tractor manufacturers across the industry took note. The safety of tractor design was no longer a purely engineering question. It was a commercial question with direct market consequences. The men who had suffered the consequences of those early design decisions were not abstractions in a spreadsheet. They were farmers like Harlan Dietrich of Lancaster County, Pennsylvania, who lost his right arm when a Fordson tipped over him in 1921, and who spent the remaining 40 years of his life farming one-handed, not because he was stubborn, but because the farm was all he had and there was nothing else he knew how to do. They were men like George Peterson of Kossuth County, Iowa, killed in the spring of 1924 when his tractor overturned while he was breaking new ground for corn, leaving a wife and 4 children whose neighbours helped plant that spring because the family had no one else to do it. They were men whose names appear in county record books and coroner's reports and church funeral records, connected by nothing except the particular way in which the machine that was supposed to liberate them from the labour of the horse turned out to be a different and more sudden form of danger. The engineering response to the overturn problem developed gradually through the late 1920s and into the 1930s. Tractor designers experimented with configurations that lowered the centre of gravity, placing engines lower in the frame, reducing the height of the rear wheels while increasing their diameter for equivalent ground clearance, widening the rear wheel tread to improve lateral stability. These modifications helped, but did not eliminate the problem, because the fundamental rotational dynamic of a tractor, pulling an implement through resistance, remains a physical reality, regardless of how the machine is designed. A tractor can always, under sufficient conditions, be tipped rearward. The recognition of this physical reality eventually led engineers to reconsider the problem from a different angle. If a tractor could always be tipped rearward under some combination of conditions, then the goal should not be solely to make tipping less likely, though that remained important, but also to ensure that when tipping did occur, it did not kill or severely injure the operator. This line of thinking led, over several decades, to one of the most important safety in the unexpected hardness of a buried rock, in the angle of a hillside, in the particular configuration of forces that could take a working morning and turn it into a catastrophe before any human being could react. That is the story of the early Ford tractor, and the men it killed, and the men it injured, and the long, slow work of making agricultural machinery safer than it was when it first came roaring into those expectant spring fields with its noise and its power and its hidden waiting danger. It is a story that belongs to the history of technology, and to the history of safety regulation, and to the history of American farming, and it is a story that is not entirely finished, because the tractors are still out there, in the fields and in the barns, some of them old and unprotected and still capable of the same rotational violence that claimed their first generation of operators. The spring still comes every year, the fields still wait, and the machines still carry within their basic geometry the same fundamental truth that the engineers of 1917 did not adequately reckon with, that power without protection is not liberation. It is only a different kind of danger, wearing the face of progress.